6C is all about volume. So it's really just all about formulas. Whenever you're doing uniform cross sections, so what that means is, like if you were to slice this a cylinder, you make slices kind of throughout the cylinder. Each cross section is a circle. You know the area of a circle is pi r squared. We just take that by how many slices you could make, which is your height. That's why your volume of a cylinder is pi r squared h. If your cross section is a rectangle, like if you make cross sections all the way through, you've got your length times width times height. All right, so if we want to find the volume of a cylinder, be very careful with circles. With circles, you always need to know the radius. So if you're given the diameter the whole way across, always find your radius. Volume of a cylinder, pi r squared h. Then we just plug in our values. These will always be calculator problems, or you'd have to leave them in terms of pi. All right, it doesn't specify, so we need 3 significant figures. Now remember, in doing 3 significant figures, decimals before or zeros before the decimal don't count. So I need 1, 2, 3 figures. All right, so example B. First, we have to find the height of our triangle. All right, so then if we look at this would be 6 since it's 12 all the way across. We know that because these are congruent sides, so my angles are congruent, and that splits it in half. So if this is 10, this is 6, we're looking for the height. 6 squared plus h squared equals 10 squared. So my height is 8. So that's my cross section is all going to be triangles. No matter where you draw your cross section, they will all be triangles. So the area of a triangle, 1/2 base times height. So in this particular triangle, my base all the way across now is 12 times my height, which is 8. So the area of one triangle here is 8. So when I find my volume of my triangular prism, basically what I'd have is 30, 48 triangles. So I just multiply, and going 3 sig figs, 1, 2, 3. Oh, and the other thing you should always end with, I always forget this. Volume is cubic millimeters because I have 3 dimensions. Okay, so the circle would be squared, area of a circle is squared, times another is cubed. This time it's centimeters cubed. So a linear is always a singular, area is always squared units, volume is always cubed units. All right, here's where you got to get a little better. It tells us the volume is 54.03. So this is a cylinder. So I'm going to first, some of you are getting way better about this. First thing I'm going to do is write out the entire formula. Then I can substitute my volume equals 50. I got to check and make sure that's right. Okay. 54 point, sometimes when I copy and paste, I can't see it real good. That's my volume, so I substitute that in place of my volume. We're looking for R, and H is 3.9. Now we need to solve for R. So I'm going to first divide both sides by 3.9 pi. So I cancel my pi, cancel my 3.9. Then I square root both sides. So R, normally when I square root, I need a plus or minus, but since this is representing my radius, you can plug this in just using your calculator. The way I would do that if you're doing it this way is do the square root first, then put a fraction bar, then put 4054.03 divided by 3.9 pi, and you should get approximately 3 sig figs. Oops, I said 3 and wrote 3. 2.10. I need that 0 for my 3 sig figs. Centimeters. Radius is a linear unit. Final answer. All right. A tapered solid is when you start with a base that's a shape and you taper it up to a point called the apex. All right. Tapered solids are, so think about like a rectangular prism with a square base. You're tapered, what it does is it's a third of the original full figure. So a pyramid is a third of a prism, of a rectangular prism. Your cone, it's like you start with a cylinder and it tapers and it's a third of a cylinder. So that's why your formula, so with this one, this is the cone specifically is 1/3 pi r squared h, because you're starting with pi r squared h, volume of a cylinder, and you need a third of it. 1/3 the area of base times height. Okay. All right. This I believe is given in your formula booklet. It's just 4/3 pi r cubed. Think of volume needs 3 dimensions, so that's why the radius is the only variable in the entire sphere. That's why it needs to be cubed. All right, so now we're going to find the volume of each solid. Okay, so think about this as a 1/3 of your rectangular prism, length times width times height. All right, so we have 1/3 times my length times my width times my height. So if you multiply all of these together, divided by 3, and 3 sig figs, centimeters cubed. Units are centimeters, volume cubed. Volume of a sphere, 4/3 pi r cubed. Notice we're given the diameter, so my radius. Typically, you're going to get points if you write the radius as 9.1 somewhere on your page. All right, so cube your 9.1 times pi times 4 divided by 3. 3 sig figs, centimeters cubed. And we're done.